All right, some more factor by grouping examples. All right, so the trick here is just look at your left half and consider this your right half. And you want to factor out the greatest common factor of each half. So the left half over here, they have an x cubed in common. So x cubed will be what I factor out here. My first term, x to the fifth, that's going to become an x squared. And then my next term, that's going to become a minus 9. Nice. The left half looks like they have a 10 in common. No x over here. So they have a 10 in common only. And then this is going to become an x squared, 10 times x squared. And then 10 times negative 9 gives us 90. Nice. All right. Both halves have an x squared minus 9. So that'll be what I factor out. They both got an x squared minus 9. And then x cubed and plus 10. That'll be my remaining pieces, right? So it's x squared minus 9 times x cubed will give you x cubed times x squared minus 9. All right, that's the idea. Is you're distributing that whole thing to the 10, and so you get this right half as your answer. But we're doing that in reverse is what we're doing here. All right, now this one has a little bit extra that we can factor on it. So if you look at the one on the left, x squared minus 9, this is going to be a difference of squares. All right, this is like if you have x squared minus y squared, two perfect squares, it's going to factor as x minus y, x plus y. So this x squared minus 9 is going to become x plus 3 and an x minus 3. And then this one won't factor any further. It's almost like a sum of cubes. All right, this is a perfect cube, but 10 is not a perfect cube. But if this was like an 8 or a 27, something like that, we would actually use the sum of cubes to go ahead and factor this further. All right, but as it is, x cubed plus 10 will not factor any further. So I took that and I factored it into x plus 3, x minus 3. All right, got that one out of the way. Let's do one with some x's and y's, shall we? Yeah. All right, it's not too bad. The left half looks like they have a 4 in common, so 4 and 12. And it looks like they have some x squareds in common. 4x squared. So this one doesn't have a y, so I'm not able to factor out a y. Okay. My 12x cubed is going to become a 3x. So kind of check that there. If you multiply these two, you get 12x cubed. And then the next one is going to be just a y. Yep, 4x squared times y. 4x squared y. And then on this, they don't have anything in common, but because we're starting here with a minus sign, I got to factor out that negative. So it's going to be negative, and then I'm going to change my signs of both of these terms. So it's going to be 3x plus y. Okay. All right, that's what we wanted to happen, actually. Yeah. The right half has a 3x plus y, and the left half does as well. So this is going to be 3x plus y that they have in common. And it's going to be a 4x squared for that first left half, and then a minus, and then it's an implied 1 there. Cool. So 3x plus y is a factor, and 4x squared minus 1 is. Again, you got to kind of look for this stuff. The older you get, you just kind of see it, I guess. The right half is a difference of squares again. All right, so 4x squared is a perfect square because of 2x and 2x. And then 1, of course, is a perfect square. So I get 3x plus y. And so this is going to factor, this half will factor a little bit further. It'll be a 2x plus 1 and a 2x minus 1. All right, don't worry too much if you're not seeing that completely. It does just it comes with experience. You learn to look for difference of squares. All right, that's about it. Cool.